This podcast is going over how to calculate the distance to Cephid variable stars. Let's do a quick review on what a Cephid variable star is. This is a star that is not in equilibrium and is actually changing its size and therefore its brightness. And it's going back and forth between being very small and compressed to very big and bloated, and it just goes back and forth. And that period that it takes to go back and forth is actually related to how bright it truly is. Its intrinsic brightness, which is very similar to the luminosity. And as you guys remember, in luminosity, temperature and the size affect it. So the bigger it is, the brighter it gets. And again, these go back and forth at a known period. And if you know how long it takes to go back and forth between brightest part, the dimmest part, and back to being the brightest, it can actually be used to determine how distant these things are. So, in your homework, you have 6 different graphs, 6 different Cephid variable stars. They are located in not a constellation, but a galaxy known as Messier 100. And using these 6 Cephid variable stars inside of this galaxy, we can determine its average distance to us. All right. Since this process is a little complicated, I'm going to walk you through the very first one so that you can do the exact same stuff for the remaining 5 and then calculate the average distance using the 6 that you have. So here's the first graph. This is the one we're going to use. You can see here that the higher it up it is, the brighter it is. And it's very bright, and it gets dimmer, dimmer, then shoots back up in brightness. It's dimmer, dimmer, and it repeats this on a predictable pattern. So if we want to know how far away this Cephid variable is to us, first thing we need to do is to determine the period of its change in brightness. Now we could do this from a maximum to a maximum. You could do it from a minimum to a minimum if it's more convenient that way. Either way is fine. And in fact, in this one, I'm going to do from the minimum to the minimum. So step 1, grab your ruler and draw a vertical line through wherever you want to measure it from. Again, it could be a maximum if you go to the next maximum, or a minimum. And that looks like, let's see, day 40, 45, 46. This is day 46. And then we go to the next minimum. Draw your vertical line. Doesn't quite look like it's 100, so we'll call that 99. So that means the period for this is the time it takes in days to go from 46 days to 99. All right, so we've got a period of 53 days. That's the period. Now, we really need to take the period and change it to the log of the period. So, using your calculator, we're going to calculate the log of 53. Log 53. Enter. So 1.72. We'll leave it at that. Now, this log of the period is actually not one of the numbers we need, but it's the number we need to determine the absolute magnitude. We'll come back to that in a minute. Next thing we need to do with our Cephid variable, all right, step 2, is to determine the average apparent magnitude. Now this little m again is the apparent magnitude, how bright it appears to us based on how far away it is. The farther away, the dimmer it would appear to be. To do that, since it changes its brightness, we need to find its average. So you're going to draw 2 horizontal lines, one at the minimums, and then again through the maximums. All right. So here we've got 24.5. And one thing you want to be very careful about when you're talking about apparent brightness or apparent magnitude, it seems a little backwards, but the lower the number, the more bright it is, or the brighter it is. So this is 24 going down to 25, so it's not 25 and a half, it's actually 24 and a half. And as this one goes even dimmer, this is going to be 25.1234. 25.4. So the average of those two, all right, if you want to calculate the average, I'll show it up here. Some people ask. So we had an apparent brightness of, make sure that, 24.5. And you add the other one, 25.4. Since we took two numbers, you got to take that, divide it by 2. So here is our average apparent brightness, 24.95. All right. That is one of the numbers we need to determine the distance. Okay. So we've got one of the numbers we need. Next we need to go back and determine the absolute magnitude. In other words, very similar to the luminosity of this star. We use that by using the log of the period. All right. So, got to flip the page over. All right. So again, we're trying to find the absolute magnitude of this Cephid variable star for the back, and what we know is that our sun has a log period of 1.72, so about halfway between 1.5 and 2 is 1.75, so ours is right about there. So if I take my ruler and carefully draw a vertical line, you're going to draw it up to this line. This line is information from the Hubble. I took a bunch of Cephid variable stars and plotted them, kind of like what you guys did for homework last night. And then up to this line, and you're going to draw it straight over. This gives you the absolute magnitude. Now, what I've done here, as you can see, is I've went through and subdivided these areas, or this section, just because you want to be as accurate on this part as possible. This is one of the numbers that will determine the distance. So if this is minus 3.35 and this one is minus 3.6, I'm falling about halfway in between there. Alright, so that will get me, if I want to go halfway in between 3.35 and 3.6, that gets me negative 3.48 for my magnitude. Alright? So let's go back and finish up the math then. So I have my apparent magnitude at 24.95, so it appears very, very dim, when in reality its absolute magnitude is minus 3.48, so it means it's very far away. So if I'm going to plug it into my distance equation, all right, I've got distance equal to 10 to the power of 5 minus my negative 3.48 plus my apparent magnitude 24.95 over 5. And bring in the calculator here. Nice glare on there. Let's scoot it over. Alright, so five minus negative 3.48 plus 24.95 divided by 5 gets me a grand total distance of 4,852,885 parsecs. All right. This is the exact same process you're going to do for all 6 of these. Got the first one done, so you've got 5 more to go. Then at the very bottom, all you're going to do is take all 6 of your distances and average them up so that you can get a good average distance for M100.